what's up, you guys? This is Elias here with Team GDI and Slam Car Productions, bringing you another installment at the Automotive Tech building. Today, I'm going to be talking to you about a simple little sensor and show you its locations. This particular sensor, I would say it's very vital when it comes to the coolant going through the engines and like other passages that it goes around into. If it weren't for this sensor, shit, your engine would not know what's hot and cold. Now for this sensor, as soon as you switch over that key in the ignition system, it starts to work. As soon as you even, let's say, turn on a light, this thing's already reading that it's, let's say, like pretty warm, like around 80, 70 degrees. But as soon as it goes up to, I believe, more than 2 minutes, I'll start reading really high. For its location, I would say most of these things land behind the passages, I would say in the engine bay. They are really tricky to get to sometimes. So let's go see where it is. Sensors like these often have the tendency to either be really deep within inside the engine bay, like I'm talking about hide and go seek type of stuff, like some professional hide and go seek. But to the trained professional eye, if you're really smart and know where to look and constant clicks, I would say you would have to just bend your head over and go within the bay. Let's see, right here. Almost right there. And right there, my friends, is the location for that certain little sensor. Small little rheostat, what it is. Just two connector wires, a signal and a ground. But I'll let my friends Kevin and Fidel explain how the electrical properties work for this little sensor.
Hi guys, my name is Fidel. My name is Kevin. And today we're going to show you the ECT sensor circuit, its components, and how they function. First off, the ECT sensor is a high authority sensor for the PCM when the engine is cold, meaning your PCM will rely on the ECT's voltage reading to supply the correct amount of fuel to the engine in cold conditions.
The ETC sensor is a 2-wire rheostat sensor. One wire is a ground circuit, right here, usually grounded to the PCM, which is this. And the other wire is power, right here. When the coolant temperature is low, the PCM applies a bifold reference right here, as opposed to which the temperature is high. This is referred to as a negative temperature voltage.
When the temperature is usually low, between 120 degrees or less, the ECT sensor voltage will be applied through a high value resistor, which we see right here. When the temperature is usually high, above 120 degrees Fahrenheit, the voltage will be applied through a much lower resistor here. This allows for a very accurate reading of the coolant temperature in the cylinder. Right here, we're going to show you what an ECT sensor looks like up close. You can see that this is a 2-wire rheostat sensor that came off of most likely a Ford. And we're also going to show you another view of it here on this engine block, Toyota engine block, right by the coolant passage here on this side.
In the next slide, we will show you Jesus properly demonstrating how to diagnose a ECT sensor.
And Jesus Macias. I am a student at the Atec program over here, and I am here to teach you how to test your ECT sensor. So first of all, you need to know where it's at. So in this part, it's over here by the side of the engine, right where I have backfill, then connect it to wires already for later testing. And what you want to make sure is that there is no broken or corrosion on the wires connecting the sensor, and just make sure that you know where it's at. Afterwards, you want to make sure that you actually have coolant in your reservoir. To do that, you just shake your coolant and make sure that you actually have some. So like here, I'm right a little bit under the max, but it still should be good enough for what I'm testing for. After you've done all that, now you can start testing with the DVO on. So first, get your DVO on, and first off, you want to check the resistance. To do that, you just set this to the horseshoe looking thing, which is a sign for ohms. Just set it there, and now it's ready to read resistance. So now you take your two test leads and you touch the back of where you backpost both wires, and it should give you a resistance reading. So as I explained earlier in the video, the higher the temperature, the lower the resistance, and the lower the temperature, the higher resistance. So now since the engine kind of barely started, the resistance is pretty high. Like as you can hear here, it's at 15 mega ohms, so it's very high. And what you would want to do is check that and compare it to specifications when you first start the car. Afterwards, you want to check the voltage. So to do that, then you set this to DC volts, which is this symbol right here with the V, with the dash line and then a dollar line right under it. Just set it there, and you can tell it's DC volts. It says DC on top. And then you want to take your signal wire. So if you know which one's your signal wire, you just check your electrical diagram, and you just connect it, one lead, and then the other lead touch the ground, and you should get a voltage reading. So on the ECT, the higher the voltage, the lower the temperature. The lower the voltage, the higher the temperature. So you can see here, so the engine's been warming up. It's going to keep dropping voltage right there. And then what you want to do with that data is compare it to specifications, depending on your vehicle and manufacturer. So now I'm going to teach you how to do it with the scan tool.
Alright, let's go.
First off, you have to connect your scan tool to the DLC connector, which is located usually inside the car under the dash. Like right here in this car, it's right here. So once you have that connected, you turn on your scan tool and you set it to read the live data stream, and it's going to show you the live data from the sensor itself. So from here you can see it gives us two values, one in degrees Celsius and one in voltage. So once you get that data, what you could do is get a laser thermometer and compare the data that you have here, and with the laser thermometer check the coolant and to see that they're at about the same temperature. That's about all that you need to know about scan tool testing.